Hello and welcome to the monthly Southwest Drought Briefing. I'm Emily Elias, Director of the USDA Southwest Climate Hub. These monthly briefings emerged during the 2020 Southwest Drought from part of the Southwest Drought Learning Network. The network links climate service providers with resource managers and resource managers with one another to increase both landscape and community resilience in current and future drought. These briefings will continue as long as there are areas of extreme and exceptional drought in our region. This briefing is being recorded and we will post it within the next week or so. I want to take a moment to thank my colleague, Joel Lisenby. Joel is the Drought Early Warning System Coordinator for the Intermountain West and Southern Plains regions at NIDIS. Joel will be moderating the questions today at the end of the briefing, and please use the question feature at any time during the talks. We begin this webinar by respectfully acknowledging that the land each of us is joining from today is the ancestral lands of Indigenous cultures. I believe it's important to provide this acknowledgement because the narratives of this land and region have long been told from one dominant perspective, without acknowledging the history and the people who lived on this land in the past. So today we are joined by two presenters. We are joined by Dr. John Meyer, and he'll give us the drought conditions update. He is a climate scientist with the Utah Climate Center and leads the Climate Center's operational weather and climate modeling platforms, as well as drought monitoring interactions and media relations. John is the state coordinator for the CoCoRa's Precipitation Network and is happy to finally start seeing snow reports coming in across the state. And then we will hear from Dr. Heidi Kratch about landscape water conservation during drought. Heidi is the urban and landscape horticulture specialist at the University of Nevada, Reno. She has been working on landscape water issues for over 15 years. So with that, I will stop sharing my screen and turn it over to John to hear the drought conditions update and short-term outlooks.
Well, hello, everybody. Thank you, Emily. Thank you, Joel. Thank you for everybody for spending a short window of time talking about the drought today. My name is John Meyer. I'm with the Utah Climate Center, and we'll be going over some of the recent conditions of drought throughout the desert Southwest. We'll begin with an overview of where we currently stand with drought conditions. 100% of the region features drought, unfortunately, and 45% of the Southwest region is currently experiencing extreme to exceptional drought. So a significant portion of the region is embedded in a long-term, multi-year significant drought. We can see the conditions present there. Looking at drought changes, we have eastern half of Colorado and New Mexico have seen increasing drought severity over the last few months, status quo for the remainder of the region, and small pockets of improvement in Northern California and Nevada. But overall, the drought degradation across Colorado and New Mexico is what we'll focus on. Looking at temperatures over the recent few months from September to October and November, the fall season has experienced warmer than normal temperatures. And we can see the map here showing temperatures across northern Utah, Colorado, and New Mexico have seen the warmest conditions. Trending into November, we've seen a significant increase in the anomalies of temperatures across the region, with many of the areas seeing the top 10 percentile to near record-breaking warmth for the month of November. So trending in the wrong direction for fall temperatures. Looking at precipitation across the region, we had a wonderful monsoon season that we've called the miracle monsoon here and there. And that really transitioned to a wet start for the fall, with August and September seeing precipitation patterns improving across many parts of the region, specifically in Utah, especially there. The rest of the region began to dry out for the fall, and that transitioned to an even drier November, where we've really flatlined for our precipitation pattern. And that has really tempered our enthusiasm from that drought improvement that we saw from our miracle monsoon and the early parts of our fall season. And now we are seeing very limited snow accumulations at the beginning of our snow accumulation season. Now we've had a hot and dry November, and what we're looking at here is the Quick Drought Response Index, which combines a conglomerate of vegetation and evapotranspiration and other hydrologic variables, as well as climate indicators, to all get an idea of how we are trending over the short term for drought conditions. This is looking at 4-week drought changes, or at least stresses. And we can see a comparison of October 31st versus December 5th. Our current map here in the middle showing quite a bit drier conditions from the Quick Dry Drought Response Index. And that shows the trend that we've been monitoring throughout the last few months, showing signs of intensifying drought throughout the region, thanks to the hot and dry November. We are currently in a La Nina season, meaning the desert Southwest should expect to see drier than normal conditions with warmer than normal temperatures. And this is the current state of snowpack across the state, looking at snow water equivalent observations from the SNOWTEL observations. And this shows the highly anomalously dry start to the wintertime snowpack season. Thanks to the last week or so, many of these basins have improved a little bit, but generally speaking, the desert Southwest is in the bottom 10 percentile for snowpack. Utah right now is at the record lowest snowpack that we've seen at this point of the year. So it has not been a great start to the snowpack season. We've really flatlined since the October atmospheric river events brought some good humidity and precipitation to the region. I will note that there's still plenty of season to rebound from our bad start. We aren't going to fall on our face the entire season, but the La Nina pattern does suppress the probability of these prolonged precipitation conditions. So that does suppress our optimism going forward that we will see a really wonderful snowpack season throughout the region. One positive note remains currently, and that's the elevated near-surface soil moisture. This is showing the 3 months difference in column relative soil moisture from the NASA SPORT model. And we had a wonderful monsoon season that brought soil moisture to record levels across much of the desert Southwest. And we're really just holding on to as much of that as possible heading into the snow accumulation season. What we're seeing right now is many of the northern parts of the Southwest are seeing improvements from soil moisture perspective thanks to some recent storms, but overall we have been trending drier across the entire region, and that's a byproduct of this hot and dry October and November. We are hoping to see limited evaporative demand going forward, so the soil moisture that we do have, which remains at fairly high levels, will be locked into place, and we will freeze that current drying trend in much of the region that we're seeing really beginning to expand into Arizona, New Mexico, and the eastern half of Colorado. So we want to stop that and lock the soil moisture in place heading into the snow season and going forward. Looking at reservoir capacities throughout the region, and we can see a pretty dire state of the hydrological drought that we are currently embedded in, despite the improvements from the meteorological drought perspective from the summer onward. And so this remains the biggest concern going forward is the region's reservoir levels, as well as groundwater reserves. Obviously, Lake Powell and Lake Mead are the big ones that we're focused on, and those remain heavily depleted at 29% and 34% full, respectively, for those two reservoir systems. The Lake Powell storage graphic on the right here shows that we continue to trend downward, and week over week, we're seeing reductions in these lake levels. And so hopefully that begins to rebound next spring, thanks to those high levels of soil moisture that will give us a little bit more effective spring runoff efficiency that we certainly did not have last year. Looking forward, the short-term weather pattern sees a return of the storm track to the western U.S., so some optimism for some short-term relief to our conditions, get a little bit more soil moisture across the region. This is showing day 1 through 7 outlook. However, the La Nina pattern that we are looking at for the rest of the season will limit these kind of weather events over the course of the overall season. So while we'll hope and cross our fingers that we get a few more of these kind of weather pattern breakdowns in the west and a return of the storm track, our expectation is that the overall seasonal summary will remain hot and dry, which you can see reflected here in the CPC's 3-month outlook for December, January, and February, with much of the region looking at above average temperatures and below average precipitation conditions. Well, a quick summary as I wrap up. Optimistic start for the fall precipitation. Really flatlined over the last 6 weeks, and now we're sitting at near record dry conditions for snowpack across the region. We do have the active weather that's forecast for the coming weeks, and that should help us rebound a little bit, but the seasonal outlook is not favorable for substantial improvements in drought across the region. However, our elevated soil moisture conditions should translate to improved runoff efficiency, and hopefully that helps recharge the region's highly depleted reservoirs. Well, that's what I have. If we have questions now or we can wait till the end, I'm happy with either. Thank you very much.
Thank you, John. That was a great update and summary. We'll hold questions, but if you do have questions, please use the question feature, enter them in, and we will take them at the end of the next presentation. So next we'll hear from Dr. Heidi Kratch, and believe that she'll be sharing her screen momentarily. All right, over to you, Heidi. If you are speaking, we can't hear you.
Sorry about that. I forgot to. Okay, can you hear me now?
Yes, sounds great.
All right, great. All right, well, thank you so much for giving me the opportunity to tell you about our extension programs here at the University of Nevada, Reno that teach landscape water conservation. And although our drought here is periodic, it has been increasing in frequency, severity, and duration in our region. So we teach citizens to adopt water-efficient landscaping practices as a regular habit. It saves the water user money, and it protects our water reserves as our population grows and our climate continues to warm. Since 2016, we have trained over 3,000 professionals and homeowners in water-efficient landscaping principles. Next slide, Joel. So domestic water use rates in Nevada are among the highest in the nation. 3/4 of household water in Nevada is used outdoors, and Nevada's population is predicted to grow by 114% by the year 2030. So here in Western Nevada, we are experiencing a boom in new home construction as well. Many of these new homes are high-end developments with significant landscaping needs, and this puts a strain on our existing water infrastructure and challenges our capacity to meet our water needs into the future. Next slide. Although 75% might seem like a disproportionately large amount of household water that's supplied to our landscapes, it really does make sense when you realize that we get virtually no precipitation during the peak growing season here in our region. So without irrigation, our landscape plants really suffer. So if you look at the graph on this slide, it illustrates the situation here in Reno. And shown are historical average evapotranspiration rates, which is indicated by the orange line, and precipitation rates indicated by the red line. And this is by month over the course of the year. The difference between the orange and the red lines represents the approximate amount of irrigation water that's needed by plants during our growing season. And because of our low precipitation rates during the peak growing season, which is July here, Our landscape plants are almost entirely reliant on irrigation to meet their water needs. So teaching about irrigation and how to do it properly is really important here. Reno typically receives less than 7 inches of precipitation annually, and most of that comes as snow melt during the winter. Last year, only 3 inches of precipitation were recorded at this weather station. So you can see how important landscape water conservation efforts are to improving the resilience of the water reserves in our region. Next slide. In addition to being dry, Nevada's urban areas are also really hot. Last year, Reno hit a record 21 days with high temperatures above 100 degrees Fahrenheit. These temperatures obviously cause stress for most landscape plants. So landscape water conservation here must be really thoughtful so that water is applied when and where it is needed most. One of the problems we have is people like to remove their lawns when we get into a drought, and they're starting to use more water. Removing a lawn during a drought to save water without planning for the water needs of existing trees stresses the trees and increases the amount of reflected light and heat in our living areas, which really heats up the living areas for people. So we need to remind people of the role landscape plants play in cooling our living areas. Trees in particular provide shade and transpire water through their leaves to cool the surrounding atmosphere. Unfortunately, trees that are not adequately watered during drought lose their leaves and therefore their ability to cool the area, which exacerbates the effects of drought on the population's well-being by worsening the urban heat island effect. This is a big problem in our area. So education here is needed that helps citizens use water more efficiently during drought with targeted irrigation of high-value plants like landscape trees. Next slide. But you might ask, by diverting water from lawns to trees, aren't we just replacing one problem with another? And the answer is not really. Woody plants use water much more efficiently than do turf grass lawns. This table shows a comparison of tree and turf grass average water requirements in July in our region. And you can see turf grass lawns use over 1.5 times more water than trees based on a similar root zone area. The calculated amounts are based on a historical peak month watering evapotranspiration rate of 9.2 inches and 1,000 square feet of root zone area. And we use the equation at the bottom of the slide. And in case you're not familiar with this, ETO stands for reference evapotranspiration and provides us with an indirect measure of how much water is lost by landscape plants. And then that second part in the equation is the plant factor, which is a number between 0 and 1, and it varies by plant type and accounts for the water efficiency of the dominant plant type within the 1,000 square foot area. So if most of it is turf grass, then we use the factor that corresponds with turf grass, which by the way is 0.8. Next slide. Now, the information on this slide is based on research that was done by my colleagues and me while I was at Utah State University. And we created a spreadsheet model that showed how much water is used in landscapes with different vegetation profiles. And we verified the model against observations of actual water use over 8 years in 3 landscapes in Salt Lake City. And you can see in landscapes of roughly the same size, about 5,000 square feet, we saw a dramatic 69% decrease in water use when comparing a landscape dominated by lawn to a landscape dominated by trees and shrubs. Next slide. So, given these facts, here are the main messages that we convey during our extension landscape water conservation programs. The main focus will vary somewhat depending on our audience. For master gardeners and general public, our focus is on selecting climate-adapted landscape plants and using turf grass only in places where it has a function. For example, areas used by children, pets, or for entertaining. We also teach simple irrigation principles like how to install and use a drip irrigation system. During drought, we recommend cutting back on lawn irrigation and prioritizing application of water to trees, since lawns are more easily replaced than mature trees are. Next slide. For landscape professionals, we drill down a little bit deeper and discuss how to develop water budgets and how to perform a lawn water audit, and then how to use that information to develop an efficient irrigation schedule for different areas of the landscape, what we would call hydrozones. We also have attendees compare the water use of traditional turf grass-based landscapes to that of sustainable landscapes, where the turf is replaced by climate-adapted plants, and weather-based irrigation controllers are used for scheduling irrigation. So on this slide, these graphs show the typical water use of a traditional versus a sustainable landscape over the course of a growing season. The bars indicate water use in gallons, and the yellow line indicates the amount of the water budget. The orange part of the bars indicates where the user has typically applied more than the budgeted amount of water. And you'll notice in traditional landscapes on the left side of the slide that people often exceed the water budget in early spring and then again in late summer and fall. And this is because of the set it and forget it mentality many homeowners have when it comes to irrigation scheduling. So these graphs demonstrate to our attendees how much easier it is to stay within a water budget. If you look at the sustainable landscape graph on the right-hand side of the slide, if you look at that, you'll see how much easier it is to stay within their water budget, which is the bars below the yellow line, when you use sustainable landscaping principles. It also shows how much less water is used on a sustainable landscape, only 2,000 gallons during the peak watering month of July versus 12,000 gallons on traditional turf grass-based landscapes. Next slide. So here's another graph that shows the benefits of sustainable landscaping. So the red and orange bars on this graph indicate the water use of sustainable, which is in orange, red versus the traditional landscapes, which are the orange bars. And the cutoff between our tier 1 and tier 2 water rates is at 6,000 gallons per month and is indicated by that horizontal yellow line on the graph. So this graph shows how applying sustainable landscaping principles allows the property owner to pay for water only at the lower tier 1 water rates. So for education purposes, we use the EPA WaterSense approved Qualified Water Efficient Landscaper program, also called Quail, to teach these principles to landscape professionals. Quail, by the way, was, if you haven't heard of it, was created by the Sonoma County Saving Water Partnership. And the program allows users in different states to slightly modify their program in order to more closely match their climate conditions. And at UNR Extension, we're also developing our own hands-on program for homeowners to teach them the basics of landscape water conservation and to help them decide at what point it would be a good idea to hire a Quail certified professional. And by doing this, it'll allow homeowners to have basic information of how to irrigate landscapes efficiently while simultaneously building the demand for our Quail certified professionals. Next slide. We also team up with local agency partners to help fund our work. Truckee Meadows Water Authority, which is the main water purveyor in the Truckee Meadows watershed, which includes Reno, helps to offset the cost of our Quail program and has funded some of the educational videos we use during our programs. Since 2018, we have trained 64 green industry professionals to pass the Quail certification exam, and 49 of those have logged continuing education hours annually and remain Quail certified through the EPA. So our residents have that resource to use to help them conserve landscape water, especially during drought. During the drought in 2015 and 2016, the Nevada Division of Forestry funded our programs that focused on keeping trees alive during drought. The program targeted arborists and other landscape professionals, and we encouraged slow, deep watering of trees in a broad and uniform pattern within the drip line and beyond the tree's drip line. These professional programs have added to the resources that are available to our community, and this helps them to conserve landscape water. So with that, I guess we can take questions now.
Great, thank you, Heidi. So Joel here from Heidi, so I'll be moderating the questions. If any of you in the audience would like to ask a question, go ahead and drop it into the questions box. We can ask questions for both John and Heidi at this time, and we're going to try to finish up. Well, we're at about 27 past the hour, so we probably have time for about one question for each of you. John, the first question that I have is for you. You mentioned that soil moisture, you used the word locked in as we come into the winter months. Could you explain that a little bit about how the soil moisture that we accumulated over autumn, how it will stay around during winter, and what will that mean as we get into spring?
Yeah, absolutely, Joel. Thanks, and good question. When I use the term locked in, this is really unpackaging two different things going on this time of year. First of all, locked in is probably best explained with just freezing the soil moisture in place. As soon as we have the topsoil that freezes, the moisture that's there and maybe the top meter or so of the soil moisture column doesn't have much of a place to go. It's not going to evaporate back out into the atmosphere. And so anywhere that freezes this time of year at the surface locks in the soil moisture, waiting to be unlocked during the spring season when the soils then thaw out. And not everywhere in the Southwest region will experience freezing soils throughout the entire season. So locked in for those areas really is talking about this cooling and limited evaporative demand in the atmosphere as the season goes from hotter and drier to cooler and cloudier, and placing less evaporative demand on the surface. So this is the time of year where we start to see less soil moisture changes throughout the region. So what we have now gets locked into place and translates to the runoff efficiency come thaw season. So we saw last spring with heavily depleted soil moistures at the surface, the snowpack, as soon as it melted, it absorbed right into the soils. And so we had a very inefficient spring runoff despite having snowpack present. And that was an artifact of just having very little soil moisture. This year, with a lot of soil moisture in place throughout the region, we're expecting the opposite with a very efficient spring runoff where less is being absorbed into the soils because we're already near saturation in many places. And that translates to more water coming into the reservoirs and down the river systems. And that's probably the most silver lining that we can find right now.
Right, thanks, John. So in other words, even if we don't see as much snow accumulate this winter as we'd hope, we're probably still in a better position than we were going into last winter.
Correct.
Yep. Thanks for that, John. We have time for just one more question. This last question is for you, Heidi. It comes from Frank. It says, Frank says, I'm not familiar with the Quail program. Is that strictly for Sonoma County, or did EPA pick that up such that Quail certified professionals can be found throughout the Intermountain West?
Yes, that's a good question. Yes, Quail was created in Sonoma County, and it's used all over California, but it's also used by other states. You have to apply to be allowed to use the program, and you have to modify the PowerPoints for your state and then get that approved as well. But yes, you'll find Quail professionals in many different states across the West. I know Utah has professionals, Nevada now has professionals more recently, but of course most of them are in California. But yes, I don't remember the other states, but there are other states in the West that do have Quail certified professionals.
And if we wanted to find a Quail certified professional, would we be able to search for that on the Quail program website?
Yeah, you'd go to, and thank you for bringing that up because I forgot to mention it. You go to quail.net, so that's QWEL.net, And once you get to that page, you can put in your zip code and then say search for professionals, and it'll come up with a list of people who are Quail certified in your region.
Okay, great. Thank you very much for explaining that, and fantastic presentation to both of you. Thanks, and very good job. I may wrap us up there. Thanks to all of you for coming along. I hope that this was useful and you learned something from the presentations today. Our next Southwest Drought briefing is scheduled for the 25th of January. We haven't locked in a time for that yet, but we'll probably be around midday again. So be watching for that in your inbox. I also would like to thank Emily, who opened up this webinar for us, for all of her work in putting these together. That's it from me here at NIDIS. I hope all of you have very happy and safe holidays. Bye.
Thank you.